Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 26 from the Smith Organic Chemistry textbook. And so this problem is basically talking about a green oxidation method using sodium hypochlorite instead of two of the chromium-based oxidation methods that were presented earlier in the chapter. And so for A, it's asking what the advantage of using sodium hypochlorite is versus using chromium on amberless resin. And so I've drawn the sodium hypochlorite oxidation out up here at the top. And so you can see that it oxidizes your alcohol substrate up to a ketone. And then the only side products that are produced are sodium chloride and water. And so I guess I don't know how much you guys know about chromium. Chromium is a horrendous chemical from an environmental and like toxicological point of view. It's a carcinogen. It's extremely toxic. It's not something that you want to work with. It's not something that you want in your environment. And so obviously this method so the answer for A is that even supported on amberless resin, that method still requires chromium, whereas this sodium hypochlorite method does not. And then so sort of in the same vein for B, a traditional, chromium trioxide, sulfuric acid, and water oxidation. So still obviously you need chromium. And then in that methodology, you have the added disadvantage of requiring sulfuric acid as well, which is a dangerous, highly reactive, caustic chemical. And so obviously this green sodium hypochlorite method has many advantages over chromium-based oxidations. As far as disadvantages, I suspect that it may not work as well, which is why it's not used synthetically as often. Whereas the chromium oxidations definitely work. They just are dangerous to work with and have horrendous byproducts. And so that is the answer to Chapter 12, number 26.